Now we'll talk about the SPICE PCK system. That's the planetary constants kernel system. And we'll talk about text PCK orientation models, binary PCK orientation models, PCK reference frames, PCK shape models, using PCKs, interface routines, precedence rules, and utility programs. So the PCK subsystem comprises both text and binary kernels. The text PCKs provide orientation and shape models for the sun, planets, natural satellites, and a few asteroids. Binary PCKs are used only when very high accuracy orientation data are available, currently available only for the Earth and Moon. And one still needs to use a text-style PCK to get shape data. So binary PCKs contain only orientation data. Text PCKs contain size, shape, and orientation data associated with a few, associated with natural solar system bodies, planets, satellites, and a few comets and asteroids. Some additional kinds of data might also be included. For example, information about rings for Saturn, Earth geomagnetic dipole direction, and so on. NAIF creates and distributes what we call a generic text PCK based on the latest IU-IAG report. These reports are issued about once every 3 years, and so might not contain the very latest available results. SPICE PCK software is designed to use these data to compute orientation of body-fixed, body-centered frames. These frames have the name style IU underscore body name, for example, IU underscore Mars. Text PCKs are sometimes produced by flight projects and others not only by NAIF. SPICE text kernel mechanism is used to implement PCK files. So this is the same format that you've already seen in the intro to kernels tutorial, with the \begin data to identify data blocks, \begin text to identify text blocks, and keyword equal value assignments. You see these vector values associated with polari, pultec, prime meridian, and radii. These assignments define Euler angles for the giving the direction of the pole and the location of the prime meridian of the body fixed frame of the object, and also typically radii for a triaxial shape model may actually have only maybe spherical or might be biaxial. We do have 3 radii to specify the shape of an object. Users can easily inspect data in text PCK because they are a text file. You can view them with a web browser or a text editor. You can modify text PCKs with the text editor. As you've probably already seen, you've got to be very careful when you do that. Some editors insert non-printing characters, or as we saw today, will change your file name, give you an extension that might not be what you expect. So one has to be very careful when editing. Data or comments can be added, deleted, or changed. Comments should be added to explain changes. Kernel variable names are case sensitive. We recommend using only uppercase for variable names. For the sun, planets, and a few major asteroids, PCK models use low degree, typical linear polynomials to represent r-index of the pole as a function of time. Prime meridian is also represented by a low degree polynomial. For a few planets, trigonometric polynomial terms are used to more accurately represent precession and nutation of the pole. For natural satellites, in addition to low degree polynomials for the spin axis and prime meridian, trigonometric polynomial terms are used to more accurately represent precession and nutation. A few satellites have chaotic rotation and so are not modeled. The base frame for PCK orientation models is the International Celestial Reference Frame, so ICRF. For historical and backward compatibility reasons, SPICE uses the name J2000, just as we do for SPK files, as a synonym for the ICRF inertial reference frame, even though these frames are not identical. So if you see the references to the PCK, to the J2000 frame in a PCK file, it's actually the ICRF. Body fixed frames provided in text PCKs have plus the axes consistent with planidocentric coordinate systems. So the plus x axis of these frames coincide with planidocentric longitude 0. For planets and satellites, plus the axis always points to the north side of the variable plane. Just as Mark said, the plane's normal vector is the angular momentum vector of the solar system. Planidocentric longitude increases positively eastward and latitude positively northward. Dwarf planets, asteroids, and comets spin in the right-hand sense about their positive pole. But SPICE documentation still refers to this as the North Pole. Positive pole can point above or below the variable plane, and this revision, made in 2006 by the IU Working Group, at first would have been the direction of the North Pole for Pluto, Charon, and Ida. Binary PCK orientation models. When available, the SPICE system can store high accuracy orientation model data in binary PCKs. These are limited to storing orientation data, so no size or shape data. Applications that require shape data must also load a text PCK for that. Orientation data from binary PCK always supersede orientation data for the same object obtained from a text PCK, no matter the order in which the kernels are loaded. However, by construction, we make sure that the binary PCKs for Earth and Moon do not use the same ID codes as are used in the text PCK, so this sort of conflict between binary text orientation models for the same object do not occur in practice. Binary PCKs for only the Earth and Moon are available for NAIF, and the accuracy of these is much better than what is provided in the generic text PCK. We'll talk about this more later, but the text PCK orientation model for the Moon is not that bad, but the one for Earth is terrible. The one for Earth is off by a full milliradian in its prime meridian location. Now, the reason that these are provided at all, you might ask, well, so why does they provide these inaccurate models? They do have the convenience of not having any time bounds associated with them, so you can use them without concern about running out of coverage, whereas the binary PCKs do have limited time coverage. PCK reference frame specifications are built into SPICE, or I should say many are built into SPICE. Examples are IU Saturn and IU Titan. To use these, load a text PCK file containing orientation data for the body of interest. Typically, this is just the current generic text PCK. Again, be cautious about using IU Earth and IU Moon. Other PCK frames are not built in and must be defined in a frames kernel that is loaded by your program. Examples are body fixed frames for asteroids or newer natural satellites, newer in the sense that they were discovered more recently. See, the frames require reading technical reference for information on creating frame kernels that specify PCK reference frames. So this required reading actually has some examples that show you the format that you have to follow to create new PCK reference frames. High accuracy Earth and lunar body fixed frames are realized using binary PCKs. These frames are named for the Earth ITRF-93 and for the Moon PA and Moon ME, which stand for Moon Principal Axis and Moon Mean Earth. To use high accuracy Earth or Moon orientation, load the appropriate binary PCK and allied FK. So these two kernels are needed for the actually, this is slightly wrong. For high accuracy Moon orientation, you need to load the binary PCK and allied FK. For the Earth, ITRF-93 is built in, and there's no frame kernel needed for that. PCK shape models are nominally triaxial ellipsoids. For many bodies, two of the axes have the same value, usually equatorial axes. These bodies have a spheroidal shape. For some bodies, one or more radii have not been determined. See the DSK tutorial for information about other kinds of shape models available within SPICE, and tomorrow we'll get into a discussion of DSK. Although many bodies are in fact modeled as spheres or spheroids, SPICE usually deals with the general triaxial case. Exception, SPICE supports geodetic coordinate transformations only for bodies modeled as spheres or spheroids. So this is really not a SPICE restriction, it's simply the geodetic coordinate system definition is based on the assumption that the reference surface is a spheroid, not a triaxial ellipsoid. RecGeo, GeoRec, DGeoGR, DRDGeo, and XFM-STA are the modules performing these transformations. You've seen XFM-STA multiple times. It deals with all of the coordinate systems supported by SPICE. And there's an exception. SPICE supports planetographic coordinate transformations only for bodies modeled as spheres or spheroids. Well, okay, that's also an exception to this. And PGR-REC, RecPGR, PGR-DR, and DRDPGR, and XFM-STA are the modules supporting planetographic transformations. PCK orientation data are usually accessed using frame subsystem or ephemeris subsystem APIs. Example, in the IU Saturn body fixed reference frame to J2000 position or state transformation. You can get either of these transformation matrices at ET by calling respectively PX form for the 3x3 transformation, the position, and SX form for the state transformation, which is a 6x6 matrix. And here's this. So these are interfaces provided by the frame subsystem. They give you matrices that transform between one frame and another. And you could also use this behind the scenes in an SPK call. Here we're looking up the state of Saturn relative to Cassini in the IU Saturn frame. The SPK data that are used for this SPK call are actually in the J2000 frame. And so PCK data are being used behind the scenes to transform that state information to a state in the output frame that's requested by this call, which is the IU Saturn frame. So this is, we mentioned earlier in the SPK tutorial that you might need to load a PCK, and this is an example where you would. PCK shape data are usually accessed using APIs needing size and shape data, such as subpoint, subsolar, illumin, etc. Interface routines for PCKs, as with all the other SPICE kernels, you call furnish to load PCKs, and you call unload or kclear to unload them. You call SX form to return state transformation. You call PX form to return position transformation. You can get the state of an object relative to another using SPK, which will use PCK behind the scenes, as we just showed. And here's yet another example, getting the state of Cassini relative to the DSN station, DSS 13, in the J2000 inertial frame. So here again, we would normally use a binary Earth PCK to give the orientation of the Earth that's needed to compute a geocentric position vector for this station relative to the center of the Earth, and then transform that to the J2000 frame so we can connect it to the position vector of the Cassini spacecraft. Note that the Earth PCK has to be loaded even though the output frame is inertial. That's because some of the data we're using are reference to the Earth body fixed frame, the ITRF 93 frame in this case. You can also extract information from a PCK file using interface routines, BOD-VRD and BOD-VCD. Each one can accept as inputs the name of an item and an identifier for a body. So in this case, for BOD-VRD, the body is identified by name, in this one by ID code. And this will simply put together these inputs to generate the name of the kernel variable that you're trying to look up. This is an input, say, specifying the maximum dimension that there's room for in the output array. This is the number of items actually returned, number of elements returned, and this is the output data. Now in Python, these will look a little different. I haven't looked at the SpicyPy interface, but I imagine that these inputs, these inputs and these outputs don't exist, and that you simply get a list of outputs. So that might be something for you to check out. The variable name is case sensitive, and we've said that names on the left-hand side of keyword equal value assignments and text kernels are case sensitive. Well, that applies here too. If you were to put in radii in lowercase, Splice would tell you you can't find the variable. Now Saturn, on the other hand, is just a body name, and body names are not case sensitive. I haven't tried this, I don't think ever, but if you were to put in Saturn here, that should not cause a problem. But the item, this is part of the variable name, that's going to be a problem if you don't use the right case. We strongly recommend just using uppercase all the time for kernel variable names. You can also use more general kernel pool fetch routines to fetch data assigned to any non-standard names that don't have the body ID embedded in the name. GC pool for character data, GT pool for double precision data, and GI pool for integer data. In text PCKs, assignments are of two types. This is just as for all of the other text kernel assignments you've seen. Direct assignments, where variable name is set equal to a value, and incremental, where variable name is followed by a plus equal operator, and then a value or values. The last direct assignment made to a given variable replaces any or all previous assignments for that variable. So when you make a direct assignment in one kernel, and then you load another kernel that has an assignment for that same variable name, the second one simply wipes out the assignment that was made previously. Incremental assignments add additional values to an existing variable. The variable will be newly created if it didn't already exist. Orientation data from a binary PCK always supersedes orientation data for the same object obtained from a text PCK, no matter the order in which the kernels are loaded. These are PCK utility programs. Brief summarizes coverage for one or more binary PCK files. Spaces generates segment by segment summary of a binary PCK file. Comment reads, appends, or deletes comments in a binary PCK. And FrameDiff samples a PCK-based frame or compares orientation to PCK-based frames. Additional utilities are provided on the NAIF website. They're not part of the generic toolkit. BFF displays the binary file format of a binary PCK, and Bingo converts binary PCK files between big endian and little endian formats. In fact, Bingo does this conversion for any kind of binary Spice kernel. Additional information about PCKs, the most useful routines document, PCK required reading, headers of the routines mentioned, Lunar Earth High Precision PCK FK tutorial, which we will present later, and brief and FrameDiff user's guides. Related documents, frames required reading, kernel required reading, NAIF IDs, and time required. And I think that's it. Any questions?